Hey guys, here we go with Real Number System SOL review. The two major things you need to remember, or three, is we're talking about the real number system. Irrational numbers can be positive or negative, and if you want to know what they look like, just put pi in your calculator. Pi and negative pi are the king and queen of irrational numbers, which means they go on forever after the decimal, and they have no pattern and they never end. They only end on our calculator because it runs out of space. Alrighty? Rational numbers are all positive and negative fractions. If it can be written as a fraction or has a fraction in it, like a mixed number, that is a rational number. When you put those in the calculator, their decimals either stop or they repeat in a pattern. Okay? Integers are all of the numbers on the perfect number line. So imagine in your head that perfect number line, -4, -3, -2, 1, 0, 1, 2, 3, 4. Those are integers. Whole numbers start with 0 and then count, whatever you want to count, 1, 2, 3, 4, 5, and go on forever. Natural numbers are the numbers you learn when you are a baby. 1, 2, 3, 4, 5, and you just keep going higher and higher and higher. The only difference between natural numbers and whole numbers is that whole includes the 0. This Venn diagram or a chart like this is something that you're going to have to be able to fill in on the SOL. You've got to know real numbers is the title. It goes at the top. You've got rational numbers and irrational numbers. They're the two princes in our story, if you remember. Pi, positive and negative pi, and anything that looks like it is irrational. Your rational numbers are all fractions. Anything that's got a fraction in it that can be written as a fraction, it's going to be rational. Because when you put it in your calculator, like 1/2, that is going to end up a decimal that stops. Or something like 1 divided by 3 is going to be a pattern, 0.33333. And it never ends, but there's a pattern involved. So that's why it's rational. Integers are your perfect number line. Whole numbers are the same as natural numbers, except whole numbers include 0. Remember that. Natural numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and on forever. So please make sure that you can fill in a chart that looks like this. All right, here we have to identify each natural number, which are our counting numbers. They do not include 0, so we're going to get rid of that right away. And we know that they look like 1, 2, 3, 4. So let's go through each one. Let's put in 18 divided by 2, which is 9. That's definitely rational, so let's go ahead and circle that. Uh-oh, this one has a fraction in it, okay? It's rational, but it is not natural because my natural numbers that I learned in kindergarten did not have decimals. Negative numbers, nope, those are integers. We definitely didn't learn about negative numbers in kindergarten. Now, I'm going to skip 6.0 for a second and go to 2/7. I'm going to go ahead and put it in my calculator. And if you see, it's got decimals, so that's definitely not a natural number. And then I'm going to go ahead and put the square root of 81 in my calculator. And that is also 9. So that is a natural number. So let's look at this 6.0. If you have a decimal and the number after it, or all of the numbers, are zeros, then it is natural. That's kind of the exception to the rule. I realize it has a decimal point, but the number after it is 0, which means that it really doesn't have to be there, so that number is actually 6. So remember that. That might be something they try to trick you with. Okay, this next number was supposed to be a drag and drop, but Miss Voss cannot figure out how to fix that, and Miss Benson is too far away, so therefore I'm just going to draw lines. It says sort the numbers by whether they are rational or irrational. Well, we know what irrational numbers look like. They look like pi. They go on forever. They never stop. So we know pi is irrational. So we're going to draw a line there. Let's start with this negative square root of 87 and see what it looks like. Holy moly. Let's look. It just kind of goes crazy. 327379053. That means this guy is definitely irrational, and I'm going to take him around the bottom here and bring him over here. He looks a lot like pi. Then we've got a decimal right here that stops. If your decimals stop, they are rational, or if they repeat a pattern, 1 3 1 3 1 3 1 3. Now let's go ahead and do the square root of 12 and see where that one goes. Look at that. Goes crazy, just like pi. Definitely irrational. Then we have a 0 here. 0 is a whole number, which makes it rational. And then we have -4 2/3. I'm going to go ahead and put this in the calculator. You would have to do -4 plus 2/3 to see what it equals. And if you notice, it's a repeating decimal, but I just wanted to show you that anything that's a fraction is going to be rational. All right, so let's go on to the next one. It says, which classifications, that's plural, of the real number system describe all of the numbers in the set? That's where this gets tricky. So that means they want to know, is every number real? Is every number rational? Is every number irrational? And as soon as a number does not fit in a set, then your answers are going to stop. So let's start with real, because that's at the top. So we know all of these numbers are real, because that's the title. So we know they are all real. Now let's decide whether or not they're rational. Well, this decimal stops. That's rational. -17 is definitely rational because it's also an integer. 2/3 is rational. It's a fraction. 4 1/8 is rational. It's got a fraction in it. And 9 squared, you could put that in your calculator if you'd like, but it's definitely rational. It's 81. Okay, so we know that all of these numbers are rational. Now it's asking us if these numbers are irrational. Well, if they're all rational, there's no way they can be irrational. So we're going to mark that out. All right, let's start with 0.5. Is 0.5 an integer? It is not. So that means that they will not all be integers. Some of them might be integers, but not all of them. Then let's start with 0.5 again. Is 0.5 whole? It is definitely not. Some of those numbers are whole numbers, like 81, but not all of them. So that means that whole cannot be an answer. Then it says, are they natural? Well, 0.5 is not natural. 81 is natural, but if they can't all be natural, then they're not part of our answer. So the only things we would choose here would be real and rational. Okay, so be careful when they ask questions. Here we go. Let's see. This says identify which statement is false. So make sure you're looking for the right thing. The product, which means multiplying, of two rational numbers is rational. That is true. Remember when we talked about rational numbers and irrational numbers and what they did to each other? If everything is rational, it's going to be rational. The sum, so that means we're adding a rational number and an irrational number, and that's going to be irrational. That's true because remember, we said irrational numbers had cooties, and if irrational numbers were anywhere, they're going to turn the answer irrational. So both of these are true so far. This says the sum, we're adding, of a rational number and an irrational number is rational. That is false, because if you have an irrational number anywhere, that means your answer is going to be irrational. So this should be irrational. And then it says the product of a non-zero, that means anything but zero, rational number, and an irrational number is irrational. That again is true because irrational numbers have cooties. So if you have an irrational number somewhere, it's going to be irrational. Alrighty, let's look at this next thing down here. It says, Drag and drop from the choices below to fill in each blank. So it says fill in the blanks to make a true statement about 0.333333333 repeating. Okay, so it says this blank is a blank since it can be expressed as 1/3. Well, is it a repeating decimal or a terminating decimal? It's definitely repeating. It just goes on forever. And if a repeating decimal, of course, is a fraction, that means it's definitely rational. Okay? So just think about things and know, okay, if it's a fraction, I know it's rational. And that's a repeating decimal. Terminating decimal means something stops. So you can work backwards also. Alrighty. Good luck, guys. We believe you can do this.